In this example, I again have two nonlinear equations. And as I look at these, I always try to think about patterns in the equations, what they really look like, what their graphs might be. I notice that I've got x squares in both equations, and I've got y squares in both equations. I also notice that in the top equation, I have one of the variables squared is positive, the other is negative. That clues me into the idea that this is probably a hyperbola. I can try to put it in that form to get a graph. This one down here, both of them are positive, so we're either going to have a circle or an ellipse, and I assume it's an ellipse because these coefficients are not the same. Remember, a circle would have the same coefficients, an ellipse they're going to have different coefficients because it's going to stretch out differently in each direction. So I'm assuming this will be a hyperbola and an ellipse, and then either they're going to have intersections or not. So let's see if we can get an idea. So this first one here, if I just put it in the standard form for a hyperbola, I would subtract the 4 to get the constant on the other side, and then divide by the -4 to get a 1 over there, right? Now what that does is it changes all my signs, so I'm actually going to write this as x squared over 4 minus y squared over 4 equals 1. Okay, and so what that did is it forms a hyperbola. It's going to open in the x direction. Transverse axis is going to be in the x direction because that's the positive variable. My box that I'm going to draw for the oblique asymptotes will be at from the center at the origin. From the center goes up to, down to, left and right to as well. So I could sketch this out. Actually, let's sketch it out over the side a little more. Utilize my space here. So 1, 2, 1, 2, 1, 2, 1, 2. I don't want a lot of detail here, but just enough to where I can tell. So it's 2, 2 in each direction, 4x4 box, and then I draw my oblique asymptotes in. And I know that this is going to open horizontally around the x-axis because that's my positive variable. Again, I'm just looking for a rough sketch. I don't need a lot of detail here. For the ellipse, or the supposed ellipse, well, I need a 1 on this side, so I divide everything by 6. That gives me x squared over 3 plus y squared over 2 equals 1. And then my ellipse, to get the major and minor axes. The major axis will be in the x direction, minor in the y, center at the origin. These are pretty quick to figure out. And then the major ellipse will be root 3. It's the square root of this denominator, which square root 3 is around 1.7. The minor ellipse will be root 2, which is around 1.4. And so in the x direction, my ellipse is going to be around 1.7 and -1.7, those two values. And then in the y direction, it'll be around -1.4, +1.4. And so it appears that, that we may have a situation with no solution. Because my ellipse is completely, according to my graph, is completely inside that hyperbola, in between the two branches of the hyperbola. It's not actually intersecting. That's my guess then. So I'm going to guess at this point that there's no solution. But I'm going to put a question mark there. I want to prove it algebraically. That's my graph, but my graph could be off. I could have done that wrong. So I want to make sure and verify that algebraically. So to verify that algebraically, I go back to the original system, and I think in solving this, probably the best strategy, now I could use a couple different things. Elimination, Actually, elimination might be really nice here. I see, well, and the way that things are lined up, maybe I'll just go with a substitution. Let's try that. Let's try substitution. Let's solve for a variable. I think the y squared is the easiest one to solve for. We'll move all this other stuff over and then substitute it in. So on equation 1, let's solve for y squared. So equation 1, I'm going to have y squared equals, if I add x squared to both sides, I get x squared. Subtract the 4, I get a minus 4. And then I substitute those in for the y squared here. So I get 2x squared plus 3 times this quantity. Instead of y squared, I have x squared minus 4 equals 6. So that's equation 2 with the substitution. And then I solve for x, right? I can solve for x here, so it's the only variable left. 2x squared plus 3x squared minus 12 equals 6. That's 5x squared. If I add the 12, that's 18. So x squared is 18/5. And the x value then is going to be plus or minus the root of 18. I can't write. 18/5. Okay. Now, if I were to simplify that, 18 is 3 root 2. So that's 3 root 2 over root 5 plus minus. And if I multiply top and bottom by the root 5, I get 3 root 10 all over 5 plus or minus. Now, of course, as a decimal, we're looking at 3 root 10 divided by 5. That's plus or minus approximately 1.9. It's 1.897, so pretty close to 1.9 there. So it appears that according to what I've solved here, the solution, there might be 2 solutions. Hey, look at that. With x values of plus or minus 1.9. Well, x is 1.9. Ooh, that's, it's between the 1.7 and the 2.0. 1.9 is in there. So maybe my graph is off. Let's continue on and see if I messed that up somehow. I don't think so, but we'll double check it. So if I plug those in, now these are my x values, plus or minus 1.9. I'm not going with the decimal here. What I'm going to do is I'm going to go back to the x squared. It's not going to matter. If I take the 1.9 and plug it in for the x, when I square it, I'm just going to get 18/5, right? It should be 18/5. Of course, I rounded this off, so I don't want to do the rounding. I want the exact value. Otherwise, it will make some mistakes. So I don't want to round. I want to go back. I could do plus or minus root of 18/5. But when I square it, it's not going to matter. The plus or minus won't matter. Once I square it up here, I'm just going to get 18/5 either way. So I'm just going to go with that and plug it in. So I get y squared minus 18/5 plus 4 equals 0. All right, so again, it doesn't matter which one I use, plus or minus 3 root 10 over 5, any of those. When I plug it in and square it, I'm going to get 18/5 right there. Okay. Now the 4, to get a common denominator, the 4 is really 20/5, right? 20/5 is 4. And when I combine those, I get y squared equals, what's that, 2/5? No, y squared plus 2/5 equals 0. That's what I get. Right, negative 18 plus 20 is 2. And then I subtract the 2/5 from both sides. So I get y squared equals negative 2/5. Now that poses a problem, because now to solve this, when I use the square root property, I need to use the square root of negative 2/5. Well, that's a complex number, right? It's imaginary. So that equals plus or minus, what's that? If I multiply top and bottom by 5, it'd be root 10 over 5i, I think. If I simplify it, I won't go through all the details, but it's definitely imaginary, right? Not a real number. So what does that tell me? Well, if I get a complex solution, something that's not real, that means the point is not on the graph anywhere, because I have to have real numbers to plot on here. So that does verify then that I have no solution. Both of the solutions I got for x turn out to be complex answers for y, which is not a possibility. So my original guess was correct. I would say there's no solution. Of course, I should always put this in a solution set, which in this case would be empty. So I'm going to use the empty set as my solution set.